classically get started, so I hope that you enjoyed your break. So next we've got Iryna Tsimashenka from Bacalhau. Over to you.
Hello, everyone. So today is my talk about Bacalhau, which is open low-cost compute for decentralized science. And I'm from Protocol Labs, and in Protocol Labs, our experience is in decentralized peer-to-peer storage solutions. So you might heard about like Filecoin and IPFS, and a significant portion of our team are researchers, or they have background in academia. And so even when Protocol Labs created their first solution, IPFS, the main users were researchers in mind for that project. And also my background is in performance optimization research of parallel queuing systems. So branch of operations research and also like signal processing. Sorry, I put quite a lot of names here. And I'm quite familiar with the systematic challenges that researchers are facing in academia, and how unfair that people who want to make this world a better place, but because of the structure of academia processes, sometimes it's very painful for them to work and to do the work that benefit the whole humanity. So it's quite nice to see the kind of this movement and this conference appears decentralized, and how many decentralized organizations has appeared in the last 2 or 3 years. And yeah, we today offer the solution is Bacalhau, which is offers like a decentralized open compute as a part of open infrastructure in Protocol Labs. With the key features is linked data by hash. So you can freeze your information and get this content address, and hash link it and reference it into your like papers. So you will have this immutable content. And we call it content identifier, right? So this link to your immutable data. We also offer open access, so it's already there, open access to your data and open compute, right? So IPFS is widely used in various open science projects. And as a result of this, we also offer reproducibility of your research, so you can get fully reproducible pipelines where you can run your past experiments. So you can think of it as a totally frozen virtual machines and containers or functions that you can rerun and use all the data pipelines and verify the past experiments that are done by someone else. So we'll see example in a moment about it. And it's also available to the data scientists at the moment, right? So quite a lot of integrations already happen with the Jupyter Notebook, IPython, and Wolfram, where they integrated already with these content identifiers. And also, this means that you can use all your available tools, Web2 available tools, where people spend like millions of their personal hours in developing SDKs and tools that are all available in Bacalhau. And you have this Web2 experience of like tools in the Web3 decentralized world. So this is like very powerful. And so the Bacalhau offers this like, compute over data, over this decentralized data. And some of the challenges that Bacalhau solves is working with very large data sets, that it's can be very difficult to move across networks because every universities are quite like siloed, and there is no access outside of universities to the data set. So and also network has like some limitations. We'll see example in a moment. And so Bacalhau offers this solution where instead of downloading the data and moving it between organizations, you send your computation, your jobs to where the data lives. So where you host these like petabytes and like terabytes of like large data, if you need to preprocess it, you just send it to the where the data lives. with Bacalhau technology. And so our vision is Bacalhau transforms the data collection and processing by giving scientists simple and first-class distributed tools and unlock new collaborative ecosystem. So, for example, let's look at the example of the collaboration that Bacalhau offers. If, for example, previously before Bacalhau, there was this data set that that is available, even if it's public, and some researchers do some experiments with it. They did research on it, and output of the research is private, so it's within the institutions. So if one of the researchers decided to to tile some of this data, and another scaled it, and the third researcher just grayscaled it, when the fourth is coming in and she wants to combine some of these outputs, what is currently happening, that she has to go and read the papers and reproduce it herself, so which takes a lot of time of her time. And with the Bacalhau, every output of these experiments is immutable and is public. So every output of this data has its own fingerprint, as you see here, this hash. And now, if you want to use outputs of some experiments, you just use those hashes, and you can access this data. And because the data structured in that way that if you hash your data and you get the kind of output, and you request this hash again, if the data changed, the hash will change again. So it's automatically automatically verify your data with these hashes. And if she decides to store it in an open distributed way, in open access, she can also do it by publishing it on the PFS. So Bacalhau offers familiar tools and SDKs. It's simplified. It's very easy to use. So we try to offer you the same local experience, and it's also we offer collaboration between universities. So a bit of technical deep dive on the Bacalhau platform. And so as a researcher, you send your compute, your script, or your algorithm, whatever you want to your algorithm, what you want to process with the data, you send it to the Bacalhau network. And it's just as easy as say Bacalhau run my job. And Bacalhau will automatically do all data administration for you. You don't need to worry about anything regarding to the data. And it offers results for you, and results are open, and you will have all the inputs, outputs in different files, and errors as well. And it's published there, and you decide if you want to keep it there published for anyone else to use, or you want to delete it there. So it's up to you. And it's really easy for researchers that just with this command is Bacalhau get job idea to get the results back. And also, so this is very simplified and easy to use. Kind of CLI and user experience. And also, so how these nodes decide to go for, how these nodes are choosing which job to run. So every node, not every node, but nodes will bid on your job. And think of it as a self-sustaining marketplace where nodes might offer lower cost or lower price to run your job. It may be because the data lives somewhere nearby, or they have just idle processor, idle servers there they want to use instead of being idle there. So also Bacalhau treats WARs and binaries and Dockers as a first-class citizen. So you can wrap your computations in a Docker or create WebAssembly binaries. And yeah, you can also get very heterogeneous hardware that is not available for you or within your institution or university. So you have GPUs, very high memory, RAMs, and just do it as batch processing as it's over here. So you just like run Bacalhau docker run, and then you get the Bacalhau list, you get the results of your computations. So if you want it now, this is already available, and it's already running, and we have several examples of academic research that's been running on IPFS, and these are some of these examples. And let's go into one of these case studies, which is Eureka. And the problem that they tried to solve was through this like Max Planck Institute with some combination of other universities. So the project Eureka launched like 2 years ago for measuring Earth temperature. And so the problem that they try to solve is that climate scientists struggle to measure accurately temperature of the ocean when clouds appear. It's hard to go through the clouds. And the problem was that hard that they had to involve 20 different instrumentations and ships and planes. And every of this instrumentation produced a lot of data, a very large amount. And what previously was terabytes and petabytes of data that lived in siloed universities and under different like data protection laws in different countries, what they decided to do, they decided to combine all of these together. And one second. And use and publish all this data on IPFS and allow these Bacalhau computations to run over this data. So it's not only like that they pass these data protection laws and academic like ownerships of the data. They let other researchers to use outputs of the data, and even now it's available on IPFS. You can get like full access to the most of this like raw data. And so, yeah, this is how they merge it together and run computations on Bacalhau. And we would like you to try it. And if you would like to run it, please come and collaborate with us. So this is our website. And you can come and join our Slack. This is our Twitter. And this QR code is our newsletter. So, yeah, come and collaborate. And thank you so much.
Thank you, everybody. So we've got a bit of time for questions, if there are anyone's got a question. Yes, let me throw the box at you. She's going to sound really mysterious to anyone listening.
Oh, yeah, but by the way, also, we have our head of product who came from the States, specifically for this data science conference, this Wes. Please also like come and say hi to him. He's also like, he's very focused on collaborations with DeSci, all the startups and institutions. So yeah, he's one of the person that you want to talk to. Yeah.
Yeah, thank you for the talk. I don't know if you may have mentioned it, but like I was just curious about like do the people offering the computes get like rewarded somehow as well?
So at the moment it's for free because so we just like built it and we offer scientists it for free. So in the future, we are researching now how to make it self-sustaining marketplace, but we will still have quite a lot of, for scientists and for scientific work, we will have quite a lot of kind of funding available. So at the moment, it's even for free. In the later, we will make sure that scientists can run their work on it, and yeah, it will be all. Available.
So we'll explore some like funding mechanisms.
Yeah. The funding mechanism at the moment is free.
Great, and we've got time for maybe one more quick question in the back, well, middle there. Yes, can you pass the parcel style maybe, or just, I don't know about, okay, cool.
Thank you, super interesting. I was wondering if you could talk a bit more about the compute process. So if I'm the researcher and I see the intermediate result and I want to change the compute, how does that process work?
Okay, so when you just, as a researcher, you run, so over here, you send your computations, you put it in a Docker container, right? And you run over, and you send it to Bacalhau to run. If you get results and you want to change something, you change your script, you wrap it again into like inside the Docker container, and you send again. And also you have the outputs. You see exactly what's happened after each run. So you have the same experience as if you run it on your local machine, if you run it on your laptop or in your desktop environment.
Okay, sounds great. Thank you.
Amazing. Thank you very much, everybody. Thank you very much.